Hi guys, Frankenstein here. Today I want us to look at capacitors. So capacitors in series in specific, as you can see the heading is saying capacitors in series. Just to have a simple breakdown before we go into a bit complex capacitor circuits. Just know how to handle capacitors in series. So let's say we're given a certain circuit. And you have a capacitor there. Just write it this way. Then you have another capacitor there, right? Now if you have those capacitors there, two of them, we've got C1 and C2, and our battery is maybe told to be E, and you know that E maybe is 20 volts, and here we've got 2 farads, and here we've got 3 farads. Yeah. Now you have two capacitors in series. So what can you say about them? What you'll say is that understand that if we had a resistor circuit where we had something like this, right? And what we would say is that this is R1, maybe R2, and then maybe that's the battery E. We would say that the current flowing there between the two resistors is the same. Maybe it's I1, right? Is the same. So current there is the same. Flowing through this first resistor is the same as the one flowing into the second resistor. It's the same current. Now also we know that the voltage will be different you'll use what will you use? You'll use the voltage divider rule. Between those two resistors, right? So remember that when I speak of current, it's I, right? And you remember the famous formula which says that Q is equal to IT, right? So in resistors, we're focusing on the current, né? And then in capacitors, we're focusing on the charge. So you'll see that the charge has the same direct relationship between the current. So meaning that same thing analysis here on the right side, that there won't be current flowing, but there will be charge. So there will be Q. And Q flowing in the first capacitor here, and the Q flowing in that section is the same. What you must make sure that you understand that capacitors in series have the same charge, so same Q in short. And then there's the same statement on resistors. The voltage will be different. So it's the same thing, same analogy. But now let's go deep a bit into it. Now we spoke about having the same charge in series, right? Because it's directly related to the current, right? Now let's go into what is the formulas we're going to be using, right? I have to specify here that it's going to be weird here, but follow that if you want to calculate the total, so C total capacitance, and this is under series conditions. conditions, you're gonna do what? You're gonna say C total is equal to 1 over C1 plus 1 over C2. So it's a bit weird. So if the capacitors are in series, the formula looks like the parallel formula from the resistors. So that's where they flip the understanding there. So meaning that we can calculate our total capacitance there. So C total is equal to, it's over 1 here and over 1, because remember 1 over C total. So meaning that for us to get C total, we can rewrite this formula to be in this manner. So remember, we can say that C total, that's over 1 by the way, C total is equal to 1 over C1 plus 1 over C2, everything to -1. And then that's, now you have it. Then we're going to substitute. So we're going to have 1 over 2 plus 1 over 3, everything to the -1. Now, remember the same formula from resistors. When you multiply the two resistors and add them on the bottom, it also works here, but let's just use this one because I just want to be relative on how this new combination of that in series works. So our answer is 1.2 farads. That's C total. So that is our total capacitance in that circuit. Right? Now let's put it on the side. You can use it a bit later on. I can remove this. So what to take here is, in series, the C total, you find it in terms of CT is equal to, over 1 over C1 plus 1 over C2. Can continue, plus continue unto 1 over Cn to net. Oh, sorry, there. Let's just leave it there so that it doesn't squeeze on the corner. So plus dot 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 close -1. It goes up to how many capacitors you're given. So that's the first formula you know now. And then now if they say maybe calculate the charge, how are you going to calculate the charge? Well, you need to know the second formula, which says that Q is equal to CV, right? Now, but for total charge, you're going to derive this from the same formula. It's going to convert to QT is equal to CT multiplied by E. Remember, it is the total voltage supplied by the battery. So that is the formula for calculating the total charge. So let's go to it. So it's going to be QT is equal to, what is CT? CT is 1.2 farads multiplied by, what is the E? It is 20. So 20. What? Remember, guys, we spoke about charge. So charge is in coulombs. So 24 coulombs. C. So that is our charge. Now, we've seen how we calculate the total charge. Now, what is the charge flowing in C1 and the charge flowing in C2? So Q2 and Q1, right? Actually, not Q1. Just write it this way. Let me write it as QC2 and QC1. So remember I said that charge is directly related to current, right? So charge is equal to IT. So these two are directly proportional, right? So if if the current flowing is the same, the charge flowing is the same through in series. So meaning that I'll say that Q total is equal to QC1 plus QC2, because not plus, sorry guys, what am I saying? Plus is equal to QC2. Remember, we said that the total charge will be found. Remember, if we had like a resistor, we would say that this is I total, and then I total will be the same current flowing here and the same current flowing there and there. So same thing, we found the total charge. So same thing, we're gonna say Q total is flowing, so same Q total will appear there and same Q total will appear there because it's in the same path. So that's how we go about it. Then what are we leaving here? I think that's about it. And tackling capacitors in series. It's about it, guys. Thank you, guys. Let's just look at another combination. Last combination. Then we leave.
Okay, I found this on the web for combination. Check it out.
Okay. So let's say we have given a circuit this way, that we have a battery there, capacitors, right? Then I say this is C1, C2, C3, and I tell you that this one is 3 microfarads, and this is 4 microfarads, and I tell you that this is 2 microfarads, right? And I say the supply voltage is 50 volts, right? Now what's gonna happen? Let's check. They say find Q total, they say find C total, and they say find the charge in, so QC2. So those are the 3 questions they want, the things they want. So let's go about it. Let's see how we're gonna go through that. So remember, I said that we're gonna start with this one. So C total, CT is equal to, since they're all in series, we're gonna say 1 over C1 plus 1 over C2 plus 1 over C3, and not forgetting the bracket to the -1 because you apply that to both sides. So C total is equal to 1 over 3 times 10 to the power -6 plus 4 times 10 to the power -6 plus 1 over 2 times 10 to the power -6. So close to power -1. Sorry there for congesting everything. Now C total, remember, put brackets there. Let's punch that in our calculator. Still gonna come out of the microcoding. You have to put the times 10 to -6. We can just disregard it at the end. So 1 over 6 plus 1 over 4 plus 1 over 2, actually not 6 there, it's actually 3. We've got our answer as what's going on with my calculator? Okay, let's do this. Run over. So my calculator is acting up on me, guys. Okay, I've got our answer here to be 0.90 microfarads. Right? So after that, we found our total capacitance. We can kill that. And then that's number one. So number two, we need to find Q total. So remember we said Q total is equal to what? Remember guys, C total multiplied by E, because this originates from Q is equal to C multiplied by V. And then now let's substitute. So Q total is equal to, can you read that part? It's not necessary. Just wanted to show you what that comes from. Then CT multiplied by E. What is CT? CT is 0.2 times 10 to the power negative 6 multiplied by 50. And what is our answer? So our answer is 46.15 microcoulombs. So that is our QT, right? Now let's jump into finding our QC2. So they're looking for the charge here. So remember I said that since QT, it is the charge here from the battery, it's QT. Now the same charge will be found in QC1, so here the first one, and the same charge will be found in QC2, and the same charge will be found in QC3. So meaning that I can say that QT is equal to QC2. Therefore, QC2 is equal to 46.15 microcoulombs. Okay guys, I think we can end it there with capacitors in series. Meet you in the next one, guys.